Hello class, this is Ms. Riggins talking to you today about arc length and sector area. Just as a refresher, we have a circle, and the circle has a radius of AB, and we can use the radius, which is the distance from the center to any point on the circle, to calculate the circumference, which is the distance around the circle, and to calculate the area, which is the space inside the circle. So when we do that using this radius, we get these measurements. Since the radius is in centimeters, the circumference is in centimeters, and the area is in centimeters squared. So what I want to look at is an arc length. But before we take a look at an arc length, let's take a look at an angle or a central angle that is made out of the center of the circle and two radii of the circle. So we have the radius AB and the radius CB, and the angle that is formed with them has these measurements. So this particular angle is almost a little bit over 51 degrees, which means out of the entire circle, which is 360 degrees, it's around 14% or 14 hundredths of the circle. And we found that number by dividing the angle measurement, the part of the angle measurement, by the whole angle measurement of the entire circle, which is 360. So when we have this angle, two things are formed. We have an arc length, which is the part of the circle that is between points A and C, and that arc length is a portion of the entire circle. So this arc length is AC is part of the entire circumference. So if I take a look at those measurements, I find that the arc length in this case measures 5.343 centimeters, which is not the length of the entire circumference. And when I were to divide the arc length by the length of the entire circumference for the entire circle, I get the same proportion, which is 14% or 14 hundredths. And as I move A so that the arc length is increased, I see that the percentage is also increased. So much so that when I get down over here to 180 degrees or something close to 180 degrees, I get that the arc length is almost half the circle. As we can see, the entire circle is circumference is 37.5, and this arc length is about half of that, which is 18.72. We also have something called the sector that is formed by this angle, and the sector is this space in between the two radii and the circle. So this shaded purple area, and if I take a look at the area of this sector, it's also an area of the entire portion of the area of the entire circle. So here's the area of this entire sector, and as you can see, the ratio between the area of the sector and the area of the entire circle is the same percentage as the ratio between the angle of the sector and the angle of the entire circle, which is 360. So those ratios are the same, and as I move to A to increase the area of the sector, I can see that that ratio between the two pretty much stays the same. Even when I get to half the circle, then the area of this sector is 56.308 centimeters squared, while the area of the entire circle is 112. Again, half the area of this circle is the area of the sector as I change A. So how can we use that for what we're doing today? Well, what we're going to be doing is we're going to be using this concept of part to whole. Part to whole. We're going to take a look at the part of the angle part divided by the angle whole, as we can see here, and we're going to compare that to the part of the arc length compared to the whole of the arc length, which is the whole of the circle, which is that those ratios are the same, and as well as the ratios of the areas are the same. So how do we do that? If we take a look here at this whole part to whole, we have part to whole. Degrees, we're going to set it up so that the degrees are on the left and length is on the right. It doesn't have to be that way. We can switch it. It doesn't matter as long as we're consistent. But I like to put the degrees on the left and the lengths on the right. And so since the part and whole of the degrees is the angle measurement and the whole is the entire angle measurement of the entire circle, which is 360, then we can change that to part to whole in that sense. So the angle divided by 360, and the part to whole for the length is the arc length, which is part of the circle, divided by the whole length of the circle, which is circumference. And we're going to use that exact same situation when we talk about over here with degrees and area. We're going to do the exact same thing, which is part to whole. We're still talking about the angle divided by 360 degrees, but the part now for area is the sector area, and the whole area is the circle area. So let's take a look at our notes. Page 131 talks about arc lengths, but first we talk about circumference, and we know that the circumference is the distance around the circle. So an arc length is a portion of the distance around the circle. And for those who don't remember the formula for the circumference of a circle, it's pi times d, where d is the diameter, or it's 2 pi r because the diameter is twice the length of the radius. So either of those is sufficient. So that's going to be used for our whole length. And then we have this arc length corollary that basically does say part to whole. In this case, they put the degrees on the right and the lengths on the left, and it doesn't matter. But we still have part, which is the measure of the arc over here. The length of the arc divided by the whole length of the entire circle. And then over here, we have the measure of the angle that produced the arc AB divided by 360 degrees. Okay, so I like to use this formula because it seems to be more consistent with what we're used to as far as part to whole. Part to whole, part to whole. Now let's take a look at the next page, page 133, because this was dealing with length. Now let's talk about what's dealing with area. So over here, we have the sector of a circle defined as a region bounded by the radii and the intercepted arc. We know here that the area of a circle is found by the formula pi times the radius squared. And then here we have our part to whole as well, where the part is the measure of the angle that produces the arc. And the whole is 360 degrees. And over here, the part is the area of the sector. And the whole is the entire area of the entire circle, which can be found by the formula pi times radius squared. Okay? Once we set that up, then we know we can solve this using the cross product property or stuff that we remember from middle school. So the next video we'll talk about some examples, but here it is. That's it.